Thank you very much, Dr. Vibhuti Prashan Sinha, sir, for giving me this opportunity. And I have tried to go with the spirit of the topic, maps and graphs. And I will, through few pictures, I will try to convey the misses that we commonly come across. This is a picture of automated refractive keratometer. This patient had pterygium, tried to take keratometry with manual keratometer, couldn't take it, but autoref could give us the reading. So what misses is, you have lot of instruments to measure the cornea, and it depends upon what instrument you have, and different instrument will read different area of the cornea, and you have to be consistent with the one you are using. And as you can see, different areas are measured by different instruments, so you can keep using the one which suits the patient. Next picture is, you can see the black cross hair. In one it is defocused and other is focused. So what is the message I want to convey through it? This is the keratometry of one of my staffs, and I purposely defocused the eyepiece to +4 and -4, and what was the result? The original keratometry value of 42.75 changed to 43.5 and 42.25 respectively. So that shows the importance of focusing of the eyepiece. Third picture, you see this, you will come across quite often regarding formula selection, IOL power calculation formula selection, and what I want to show you is the Wang or WK adjustment, Wang-Koch adjustment. So what is that? In long eyes, what happens in ultrasound biometry and optical biometry? In ultrasound biometry, there is differential measurement of different segments of the eyeball, and a machine is fed in a way that it will measure at different velocity. But in optical biometry, a refractive index is considered uniform all across. In long eyes, what happens? Because the posterior segment is constituting the major portion of the eyeball, so there the differential refractive index plays a role, and an error creeps into. To take care of that error, various approaches have been advised, and Wang-Koch adjustment optimization is for that error only. And by this formula, it gives a correction factor for the measured axial length by optical biometry. This normally we ignore. We think optical biometry will be the answer. So no, it is not like that. If we are using, then go for the optimized, WK optimized formula version of the corresponding formulas. So now whenever you see this picture of WK adjustment, now you understand what it is. This is another picture. This is the normal spike you will get on optical biometer. So with ultrasound biometer, you get spikes at different planes, cornea, anterior lens capsule, posterior lens capsule, and then retina. Here, only tall one spike with a dot, with a round circle at the top you are seeing. So why it is like that? When it can take a measurement of anterior chamber depth, why it doesn't take lens thickness? So basically, the consultant with IOL Master 500 and with Lens Star were different. Lens Star will give you lens thickness, but IOL Master will not give you lens thickness, IOL Master 500. The reason being, the consultant for IOL Master 500 was Haigis, and for Lens Star 900, Olsen. For Haigis formula, you don't need lens thickness. But for Olsen formula, lens thickness is the must. It gives the concept of C constant. So basically, it is not that that machine could not take, but the way the scientist who designed it in his formula, he didn't need that. So he didn't incorporate that into the measurement. And this issue has been addressed now with IOL Master 700, where you get the longitudinal cross section of the whole eye from anterior to posterior surface, and apart from that, you can measure the decentration tilt of the crystalline lens also. Then paying some attention to the spikes of the A scan, if you look at the 3 scans, what you see, the axial length is 23.87 in first, and 23.85 in second picture. This is the axial length, same patient. done by 3 different optometrists. So first and 2 readings, okay. Third reading, what is the axial length? 23.63. So same patient, there is a difference. Now how will you say what has gone wrong with this scan, third scan? If you look closely at the various spikes, you see you get it from cornea, then anterior lens, posterior lens capsule, retinal spike, and sclera and orbital pad of fat. It is present. Here if you see after retina spike, there is no scleral spike. So this will happen if your probe is focused towards optic nerve head. So paying attention to the details of the scan quality, you can have some idea. Here you see same patient, spikes are broad, but when I reduce the gain, each spikes are clear. Then this is a patient, mature cataract, and a scan was done. Well, you see here the cornea and anterior lens capsule, posterior lens capsule, and in between tall spike is there. What I want to show you is look at the lens thickness. Anterior chamber depth is 3.49 and lens thickness is 3.94. For a mature intumescent cataract, you will never expect a lens thickness of 3.94. So now what to do? What has gone wrong? If you look at these arrowheads, which are called gates, so this is not at the anterior lens capsule. This is at the third spike. So that third spike is from the dense nuclear core. After lens capsule, fluffy cortex, and then dense nuclear core is there. So machine has picked up the spike from that dense core. So what I did, I dragged that spike from this lenticular spike to anterior lens capsule. So now you can compare, this is the original one and this is the adjusted one. So what difference it has made? Now you can see the lens thickness is 5.25 and axial length has changed from 24.36 to 24.44. So to conclude, paying attention to the maps and graphs we come across gives us insight into finer details and help us improvise the final outcomes in cases of biometry. Thank you very much.